It was born in a river. It will cross an ocean. It will return to the exact gravel bed where it hatched, navigating thousands of kilometers through open sea using the Earth's magnetic field and the chemistry of the water itself. And it will arrive within meters of the precise spot where its life began. Then it will spawn. Then it will die. And its decaying body will fertilize the forest around the stream, carrying marine nutrients from the ocean into the heart of the land, feeding the trees and the insects and the birds and the bears and the next generation of salmon growing in the gravel below. The salmon is not just an animal. It is a nutrient delivery system for entire ecosystems, a biological pump that moves energy between the ocean and the continent, and one of the most physically extreme athletes in the animal kingdom. What it does across a single lifetime would be extraordinary for any creature. For a fish, it is almost beyond accounting. This is the story of the salmon's life, and it is one of the strangest, most brutal, and most ecologically important stories in all of nature. The egg is laid in gravel, specifically in a red, the nest that the female salmon excavates in the stream bed by turning on her side and beating her tail against the gravel, displacing it and creating a depression in which she deposits her eggs. The male fertilizes them. The female then displaces more gravel upstream of the nest, which washes downstream and covers the eggs, burying them in clean, oxygenated gravel, where the water flowing through the gaps between stones will bring them oxygen and carry away their metabolic waste for the months of incubation that follow. The location of the red is not random. The female selects it with a precision that reflects millions of years of evolutionary refinement. The gravel must be the right size, neither so fine that it compacts and cuts off oxygen flow, nor so coarse that the eggs wash away. The current must be the right speed, fast enough to oxygenate the gravel, but not so fast that it scours the nest. The water temperature must be within the range that the eggs can tolerate. The female assesses all of these factors with sensory systems that are not fully mapped by science, and she chooses. The eggs incubate for weeks or months, depending on species and water temperature. Cold water slows development. Warm water accelerates it. And the timing of hatching is calibrated to the season in which the juvenile fish will have the best chance of finding food and avoiding predation. When they hatch, the alevins, the newly hatched salmon with their yolk sacs still attached, remain in the gravel, absorbing the nutrients of the yolk sac, hiding from the current and from predators, completing the development that birth interrupted. When the yolk sac is absorbed, the fry emerge from the gravel and begin feeding. This emergence is one of the most dangerous moments of a salmon's life, and dangerous is an understatement. The survival rate from egg to adult salmon varies by species and by location, but across Pacific salmon species, the average is approximately 1 to 5%. Out of every 100 eggs laid, between 1 and 5 fish will live to reproduce. The rest will be eaten, will starve, will be diseased, will be stranded by low water, will fail to survive the winter, will die of the 1,000 specific ways that a small fish in a river full of larger things can die. The fry grow into parr, the juvenile salmon stage characterized by the distinctive parr marks, vertical bars of darker pigmentation along the flanks that provide camouflage against the gravel of the stream bed. The parr live in the river for months or years, depending on species, feeding on invertebrates, growing, surviving. They are already extraordinary fish for their size, territorial, aggressive, capable of holding position in fast current that would exhaust most fish of equivalent size. But they are still freshwater fish, their physiology tuned to the specific chemistry of freshwater, unable to survive in saltwater. Then something remarkable happens. The parr undergoes smoltification. Smoltification is one of the most complete physiological transformations in the animal kingdom. A process in which the juvenile salmon's entire body chemistry is rewritten to prepare it for life in saltwater. The parr marks fade. The scales develop a bright silver coating. The body shape changes, becoming more streamlined. The kidneys, which in fresh water must continuously pump out the water that osmosis drives into the fish's body, are reconfigured to conserve water against the osmotic pressure that salt water will exert in the opposite direction. The gills develop the capacity to actively excrete salt, rather than absorb it. The endocrine system that governs all of these changes runs a months-long program of hormonal shifts that the fish's nervous system cannot consciously direct, but that proceeds with the automatic precision of a developmental program written in the genome. The smolt that emerges from this process is physiologically a different animal from the par that preceded it. It is now capable of surviving in salt water, and it is driven by an impulse that researchers call migratory restlessness, a behavioral state of increased activity and downstream orientation that pushes the smolt toward the sea with an urgency that has no freshwater equivalent. The downstream migration is dangerous in its own specific ways. The smolt is moving through the predator gauntlet of the river, the herons, the otters, the larger fish, the bears, while simultaneously managing the physiological adjustment of smoltification, which is metabolically demanding and leaves the fish temporarily more vulnerable to stress and disease. The smolts travel in loose groups that provide some protection through the confusion of numbers, and they move primarily at night to reduce exposure to visual predators. They reach the estuary, the mixing zone where fresh water meets salt water, and they pause here for days or weeks, completing the final adjustments of smoltification, acclimating to the gradually increasing salinity, preparing for the open ocean. The estuary is itself a rich feeding environment, full of the invertebrates and small fish that the smolts need to fuel the rapid growth they will achieve in the ocean, and the time spent here is not wasted time, but essential preparation. Then they leave. They enter the ocean, and they disappear. For months or years. 1 year for some species, 4 or 5 years for others. The salmon live in the open ocean in ways science has only recently begun to map with any completeness, because tracking a fish across thousands of kilometers of open sea was not possible until the development of modern tagging technology. What the tags have revealed is extraordinary. Pacific salmon range across the entire North Pacific Ocean, traveling thousands of kilometers from their natal rivers in organized, productive migrations that take them to the most productive feeding grounds in the Pacific ecosystem. The sockeye salmon of the Fraser River system in British Columbia travel as far as the western Aleutian Islands, approximately 3,000 kilometers from their home river, before turning and beginning the return journey. They do this not by accident, not by drift, but by navigation, following the Earth's magnetic field and the chemical signatures of ocean water masses with a precision that GPS-assisted human navigation can barely improve upon. The ocean phase is the growth phase. The salmon that entered the ocean as a smolt weighing a few grams returns as an adult weighing several kilograms, having converted the extraordinary productivity of the North Pacific food web into body mass at a rate that no freshwater environment could support. The abundance of the ocean, the rich krill and small fish that the salmon feed on, produces growth that the river cannot provide, and the salmon's physiology is calibrated to exploit this abundance maximally during the ocean years. Then the magnetic sense triggers. The chemical memory of the home river activates. The salmon turns and begins the journey back. The return migration is the part of the salmon's life that has captured human attention and human imagination most completely, and it deserves every bit of that attention because it is genuinely one of the most remarkable things any animal does. The salmon navigates from the open ocean to the coast of its home continent, then along the coast to the mouth of its home river, then up the river for tens or hundreds of kilometers, past waterfalls and rapids and dams, against the current, without eating, burning its own body fat, and eventually its own muscle protein as fuel for a journey that may take weeks. The navigation mechanism is layered. In the open ocean, the salmon uses the Earth's magnetic field as a map reference, detecting both the intensity and the inclination angle of the field, and using the specific combination present at its natal river's latitude to maintain orientation toward home. As it approaches the coast, it switches to chemical navigation, detecting the specific trace chemical signature of its home river, the particular combination of minerals, organic compounds, and biological metabolites that make each river chemically distinct, and following that chemical gradient upstream. The chemical signature of a river is remarkably specific. Salmon can distinguish their home river from adjacent rivers with a chemical similarity that analytical chemistry finds difficult to characterize. The olfactory system that the salmon uses to do this, the smell-based navigation that guides it from the ocean to the specific tributary where it was born, is among the most sensitive and specific chemical detection systems in any animal, capable of detecting and distinguishing compounds at concentrations measured in parts per trillion. The journey up the river is physiologically extreme. The salmon that enters its home river has stopped eating. It will not eat again. Every caloric demand of the spawning migration, the muscular effort of swimming against strong current, the leaping of waterfalls, the fighting for position at the spawning grounds, the construction of the redd, the mating itself, will be met by catabolism of its own body mass. The salmon consumes itself to return home. The body changes are dramatic and specific. Hormonal cascades, triggered by the return to fresh water, initiate a sequence of physical transformations that are different for males and females. Male salmon develop the hooked jaw, called the kype, an exaggerated curved lower jaw that serves as a weapon in the fights for females at the spawning grounds. Their bodies redden. The silver of the ocean phase replaced by the deep red-green coloration of the spawning adult. Female salmon develop the distended abdomen of egg development. Both sexes begin the systematic breakdown of their own muscle protein to fuel the metabolic demands of reproduction. The waterfall is the image most associated with the salmon's return, and it is accurate in the sense that many salmon rivers do have waterfalls or rapids that require the fish to jump. The jumping ability of the salmon is extraordinary. A coho salmon can clear a vertical drop of approximately 2.5 meters, which is equivalent to a human jumping roughly 3 times their own height straight up. The jump is powered by a tail-driven acceleration from below the waterfall, the fish building speed in the tailwater before launching itself into the air and driving its body upward with a muscular effort that consumes in seconds the caloric equivalent of hours of normal swimming. At the spawning grounds, the fish that have made the journey gather in the gravel shallows where the current speed and the gravel size match the requirements of the redd. The competition for position is fierce among the males, which fight for access to females using the kype and their body mass, bearing wounds from these fights without the distraction that a healthy immune system and pain response would provide in a fish that was not already systematically shutting down its own biological systems. The spawning itself is brief. The female releases her eggs into the redd she has excavated. The male releases his milt, and in the cold, oxygenated water of the gravel bed, fertilization occurs. The eggs settle into the gravel. The female covers them with a final sweep of her tail. The cycle is complete. The fish begin to die within days. The immune system, which has been suppressed to allow the body to direct all available resources toward reproduction, fails to resist the fungal and bacterial infections that accumulate on the spawning fish's deteriorating body. The organs that have been metabolized to fuel the migration. The stomach has atrophied, the intestines have shrunk, the liver has been partially consumed, cannot recover. The fish that has crossed an ocean and a river to reach this gravel bed will not leave it. What it leaves instead is nutrients. The body of a spawned-out salmon contains marine-derived nitrogen and phosphorus that the river system, without the salmon, would never receive. A single adult salmon represents approximately 140